Hi students, good morning. Today we will discuss regarding derive an expression for a couple acting on an electric dipole in a uniform field. Suppose you know that uniform electric field means electric field intensity will be same at all the points, right? Suppose here derive an expression for the couple acting on an electric dipole. Dipole means it has equal and opposite charges. Those two charges placed in a uniform electric field. Then we have to derive the equation in that case. So here let us consider a uniform electric field. This is the uniform electric field, and you just place two charges, equal and opposite charges. So here I will place minus q charge, here I will place plus q charge, minus q charge, and this is the plus q charge. What will be the force acting on this charge and on another negative charge? And these two charges are separated by a distance of 2L. From here to here the distance is 2L. Then what happens? This field will be acting in this direction, and this force will be acting in this direction, and this force will be acting in this direction. Then what about the force? We know that electric field E is equal to F divided by Q naught. But here Q naught value is plus 1, but Q value is plus Q. So it becomes F is equal to E into Q naught. Q naught value, you know that Q naught is equal to test charge, that is plus 1 coulomb. Then what happens? F is equal to E. What is the expression for E? 1 by 4 pi epsilon naught Q1 Q2 by R square. But Q1 is what? Plus Q. Q2 is what? Plus 1 by R square. It becomes like this. So here F is equal to what? E into Q. I can write simply, no need to write this expression, just you have to substitute EQ. Okay. So now F is equal to EQ. Okay. And here also F is equal to EQ. This is negative charge and this is the positive charge. Now what I'll do? I'll just take dotted line. I'll extend these lines. I have just joined it. I'll write this outside from the field. See, it is in the uniform field. I can write here also. If I have joined this with a dotted line, this becomes theta, right? If this is a theta, this is opposite side and this is adjacent side and this is hypotenuse side. Suppose if I want trigonometric function sine theta value, then the sine theta will be is equal to what? Opposite side by hypotenuse. Opposite side by hypotenuse. So what is the opposite side for this theta here? This is the opposite side. So I just name it as a points triangle A, B, C. Okay. What is the opposite side? BC is the opposite side. So I'll write BC by, what is the hypotenuse side? AB. So AB I'll write here. Right? So now sine theta is equal to what? Sine theta is equal to BC by AB, or BC is equal to, if you cross multiply this equation, BC I have taken outside, AB into sine theta, AB into sine theta, or BC is equal to, AB value is what from this diagram? 2L it is. This is hypotenuse, right? This is hypotenuse. And what is the distance from here to here, A to B? 2L. These two charges are separated by a distance of 2L. So AB is 2L. 2L sine theta. This is the value of BC. BC value is 2L sine theta. Now got it, right? So what will be the formula, general formula for the torque acting on a dipole? Torque is equal to, it is force into displacement. Torque is equal to force into displacement, or perpendicular distance between the two charges. So what is the perpendicular distance here? BC is the perpendicular distance. What is the force here? EQ is the force here. So now torque is equal to what? Force into perpendicular distance. Force into perpendicular distance between the two charges. Right? Now what is the force? Force is equal to EQ, any one charge. Either you can take positive charge or negative charge. Both the magnitudes, we are considering only magnitudes. So EQ, write it E into Q into perpendicular distance. Perpendicular distance is what? BC. Now E into Q as it is into BC is what? 2L sine theta. Okay. So we know that dipole moment expression, we know that dipole moment P is equal to Q into 2L. This is the expression for dipole moment. P is equal to Q into L. You see, Q into 2L is there here. So now what I'll do, first I'll write the term Q into 2L in one bracket. Then I'll write E here. Then I'll write sine theta. Then what happens? Instead of Q into 2L, I can write dipole moment P. So I'll just write, instead of Q into 2L, I'll write P into TE as it is, sine theta as it is. Right? This is the expression for torque. So this is the couple acting on an electric dipole in a uniform electric field. Torque is equal to what? PE sine theta. This is the general equation, and if you want to mention this torque in an vector form, then torque is equal to P cross E. P cross E. This is about torque acting on a dipole placed in an electric field. I think you have understood this. And after that, I want to discuss the derivation of axial line. Means whenever a positive test charge placed in an axial line. So now we will discuss electric field at a axial line. So similarly consider two charges. Suppose this is at point A, you just place one charge Q, okay, and you just place another one more charge at B. You just take it as this is as a plus Q, and you just take it this is as a minus Q, and the distance of separation between these 2 points or these two charges is 2L, okay, and this is the midpoint. Center of these two lines is called as O, okay. Now the distance of separation from O to B is L, and O to A is also L. Okay. Now we just consider a positive test charge placed at P plus Q naught, that is test charge at a distance R from O. So now this distance from here to here, this distance is R, right? So now see, this is positive charge. Even test charge is also a positive charge. Positive charge. What happens? Repulsion arises. So EA will be in this direction or E1 will be in this direction outside because repulsion will arise. See, notice this. This is a negative charge. This is a positive charge. Positive, negative. What happens? Attraction arises. So E2 will be in this direction. E2 will be in this direction. Attraction arises. But due to A and P, it is away from that. Field will be away from that. Repulsion arises. But here negative and positive charge is there. So attraction will arise. So E2 will be in this direction. So now you just go for the equation. What about this distance? Complete distance from AP. From this diagram, what is the distance of AP? R. This is complete R. From here to here it is R. Okay. And this is L. So AP distance is R plus L. What about BP distance? From the diagram, this is R. Okay. And this is L. So if you want to get this distance, what I need to do? This R minus L I have to do. This R minus L I have to do. So BP is R minus L from the diagram. Now you know that electric field intensity at plus Q. At plus Q. E is equal to, what happens? 1 by 4 pi epsilon naught Q1 Q2 by R square. Q1 is what? Plus Q. Q2 is plus Q naught, means plus 1 it is test charge. So plus Q. Q it is, this is plus 1. Okay. By distance AP square. R square means AP square. AP square. R square means AP square. So now 1 by 4 pi epsilon naught Q into 1 Q. AP square is what? R plus L. AP value is R plus L. Square is there. So R plus L whole square. Now this is 1, E1. Then what about E2? Similarly, 1 by 4 pi epsilon naught Q1 Q2 by R square. What is Q1 here? Minus Q. But only magnitude we have to consider. So Q. What about test charge? Plus 1. So it is Q only. Q divided by, what is the distance? BP. OP minus OB means R minus L. R minus L square is there. Because BP square, right? BP square means R minus BP square means R minus, first you just write it as a BP square. Now you just write it as 1 by 4 pi epsilon naught Q divided by BP square means R minus L square. This is equation E1. This is for positive charge and E2 is for at negative charge. So E1 and E2 we got. So now field will be equal to, total field is equal to E1 minus E2. Now E1 minus E2, you just substitute E1 and E2. E is equal to E1 minus E2. E1 value is how much? 1 by 4 pi epsilon naught Q by R plus L whole square minus E2 value is what? 1 by 4 pi epsilon naught Q divided by R minus L whole square. Right? So now you just take it common from this equation. Q, here 1 by 4 pi epsilon naught and Q, both are common from this equation. Now you take Q divided by 4 pi epsilon naught as a outside. What is remaining? 1 divided by R plus L whole square minus 1 divided by R minus L whole square. Correct? So now take LCM of these two. Q divided by 4 pi epsilon naught as it is. R plus L whole square, R minus L whole square. What is that? A plus B whole square, A minus B whole square, A square plus B square. So now you just take it, no need to go for LCM, just A plus B whole square into A minus, yes, A square, A plus B square, A minus B whole square, A square minus B square. Okay, A plus B into A minus B, A square minus B square, A square minus B square, like this. Okay, now here what happens here? R minus L whole square minus R plus L whole square. If you observe this, how it is A minus B whole square, this is just like A plus B whole square. Expand in that way, so it becomes Q divided by 4 pi epsilon naught A minus B whole square, A square plus B square minus 2AB minus of A plus B whole square, A square plus B square plus 2AB by as it is R square plus L square whole square as it is. See, here this is plus R square, here it becomes minus R square. Plus into minus, minus. Here plus, plus into minus, minus. Plus L square minus L square gets cancelled. Here minus is there, here plus. Plus into minus, 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 minus 4RL. So it becomes 4Q into 4RL. Only magnitude we have to consider. So 4RL divided by R square plus L square whole square. Here already 4 pi epsilon naught is there. Okay. Now coming to here. What about dipole moment? Dipole moment value is P is equal to Q into 2L. So in that format I have to write this equation. So E is equal to, we know that P is equal to Q into 2L, right? Okay, now you just arrange this. E value is equal to, you just write 1 by 4 pi epsilon naught as it is, Q as it is, 4RL is there. So I'll write it 2L into 2R. 2L into 2R because I need to Q into 2L I need, because that value becomes P, dipole moment. Remaining downside R square plus L square whole square. Now just instead of Q into 2L, just you substitute P value. So P divided by 4 pi epsilon naught into 2R as it is. Here 2R is there as it is. This is R square plus L square to the power of whole square. If in case R is greater than L value, suppose very greater than L value, then what happens? This equation P into 2R divided by neglected. This L is neglected. Means L becomes nearly equal to 0. In that case what happens? 4 pi epsilon naught R square plus 0 square. What happens? R square only. R square whole square, R to the power of 4. R to the power of 4. But here 1 R is there. Here out of 4 R, 1 R gets cancelled. Then what happens? E is equal to P into, or I can write P into 2. 2P divided by 4 pi epsilon naught R cubed. This is the expression for electric field intensity placed in an axial line. What is the expression for this? 2P divided by 4 pi epsilon naught R cube. This is the expression for this axial line, I can say E is inversely proportional to the cube of the distance of separation. E is proportional to 1 by r cube. This is about axial line. In the next class, we will discuss equatorial line. Thank you.